Welcome back to the deep dive. Our whole mission here is to take a pile of, well, really dense source material, pull out the most important stuff, and just give you the shortcut.
Exactly.
And today we're really getting into the weeds of GitLab's organizational structure. We're skipping past the basic Git commands, the stuff everyone knows, and focusing on the layer that actually lets big companies function, the administrative architecture.
And we are zeroing in on one thing specifically, and that's groups. If you've ever used GitLab, you're interacting with them all the time, but their true power really stays hidden until you're the one who has to manage them.
Groups. It's such a simple name, isn't it? It sounds so basic.
Like a folder.
Exactly, like a folder. But if you're trying to manage a big product or coordinate a bunch of teams, you realize very quickly that the simple idea is actually the engine for the whole platform.
That's the nut we're trying to crack today. People just mistake a group for a collection of things, but in GitLab, it's the absolute foundation for your security, your access, your whole workflow. If you get groups, you get how to run GitLab.
Okay, so let's start there with that initial confusion. I see projects, I see groups. A project is pretty clear, right? That's where the code is, the repository, the issues are all tracked there. So if a project is the work, is a group just the bucket you put it in?
That's a good starting point, but it misses the most important part. Think of it like this. The project is the content, yes, the code. But the group isn't a passive bucket. It's a smart container.
The smart container.
Yeah, it holds projects, sure, but the critical thing is that it also holds people and permissions. And that's what turns it from a simple folder into a real administrative tool.
People and permissions, that right there sounds like the game changer. It immediately points to, well, making an admin's life a lot easier.
That's where all the power is.
So let's imagine a scenario, one that every admin dreads. You have a new engineer, let's call her Sarah. She joins the team, and she needs access to, 50 different microservices her team owns.
Right.
If I have to go into project 1, add Sarah as a developer, then go to project 2, add her again, and do that 48 more times. I've just lost a day.
You haven't just lost time. You've built a system that just doesn't scale. It can't. And that is exactly why the whole thing is built on the single most important feature of
Groups, which is inheritance.
Inheritance. Okay, that word alone immediately makes me think efficiency. The idea that you set something once up high and it just flows down.
Precisely. Inheritance is the magic that lets permissions and roles just cascade down the whole structure. So let's use your example. Imagine the top-level group for the whole company is, say, Tech Corp.
Okay.
And inside that, you have a subgroup called engineering. And that's where your 50 projects live.
So if I add Sarah way up at the top to Tech Corp, am I giving her the keys to the entire kingdom?
You could, yeah, depending on the role. But more realistically, you'd add Sarah to the engineering subgroup. The moment you do that, she inherits access, and that specific role, like developer, to all 50 projects inside it.
So you manage the user once.
Once. At the highest level, that makes sense. The system does all the heavy lifting. It's built from the ground up for managing users at scale.
Okay, I see the efficiency, but that brings up a huge question, and I know our listeners thinking it too. Isn't that a massive security risk? What if Sarah needs to be a developer on 48 of those, but a maintainer with more power on just 2?
Perfect question, because that gets to the nuance. The system is smart. It's designed to always favor the highest access granted.
Oh.
So you make her a developer at the engineering group level. She gets that role for all 50 projects by default. Then you go into just Project 49 and Project 50, and you manually assign her the maintainer role there.
And that specific higher level permission wins out.
It overrides the inherited one, but only for those 2 projects. So the administrative work completely flips. Instead of 50 manual grants, you do 1 grant, and then just 2 exceptions to grant higher access.
You go from a model of granting everything to just managing the exceptions.
Exactly. That's why this is so critical for big organizations.
Okay, that deep dive on inheritance is super helpful. But it all depends on having a good structure to begin with, which I guess leads us straight into the hierarchy.
It does. The structure is everything.
How deep can this go? We've talked about a group and a subgroup. Can you just keep nesting them? A group and a group and a group.
Oh, yeah. That's the whole idea of the subgroup structure. And the key number to remember here, the detail that matters, is that GitLab lets you nest them up to 20 levels deep.
20. That sounds, frankly, absurd. I can barely keep track of 3 folders on my desktop. Why would anyone on Earth need 20 levels?
You hope you don't need it. But the system has to be able to map to the most complex corporate structures you can imagine. We're talking massive global companies.
Can you give me a real-world example of what that might look like?
Sure. Imagine level 1 is global holdings, level 2, Asia Pacific region, level 3, financial services, 4 is the Shanghai office, 5 is compliance, 6 is Team Alpha.
Okay, I'm already getting lost.
And only then, at level 7, do you get to the actual project. And even then, you might need more layers for internal versus external APIs or for different security audit requirements. That depth is there so that your security rules can perfectly mirror your actual business structure, which is a must-have for compliance.
So the 20-level limit isn't for day-to-day work, it's for administrative and auditing sanity.
Bingo. When an auditor asks how you keep Team Alpha's code separate from Team Beta's in London, the hierarchy is your proof.
Right, and that power, combined with inheritance, means the settings at the very top become incredibly important. Which brings us to visibility rules. I know this trips a lot of people up.
It's the visibility trap, and it's probably the most rigid, unbreakable rule in the whole system.
So let's lay it out. Let's say my top-level group, Global Holdings, is set to private. Only members can see it. Can I go way down to level 5 and make one specific project public? Maybe it's an open source tool we maintain.
Absolutely not. The rule is simple and total. A child cannot be more visible than its parent. If the top group is private, everything under it, all the way down, can only be private.
The analogy you used before is perfect for this. If the whole house is locked, you can't just leave a bedroom window wide open for the public to climb through.
That's it, exactly.
Yeah.
The parent sets the visibility ceiling. If it's private, the kids can't be public. If it's internal, so visible to anyone logged into your company, a child can be internal or private, but still not public. It's a hard-coded security guarantee.
So the hierarchy does two things. It pushes access down through inheritance, and it pushes restrictions down through visibility.
It's a two-way street of control. The hierarchy is the security model.
Okay, so we've got the admin control with inheritance and the security with hierarchy. What about the practical side? How do we actually find this stuff?
And that takes us to namespaces. Every single group you create defines a namespace. It's basically the unique address for that spot in the GitLab world.
And that address is just a direct reflection of the hierarchy we've been building, right?
A one-to-one mapping. If your main group is Global Holdings and the subgroup is Asia Pacific Region, the URL is literally gitlab.com Global Holdings Asia Pacific Region. The namespace is just the path.
That's so clear. If you understand the org chart, you know the URL. It's like a street address for your code.
And that predictability is crucial, not just for people browsing, but for all your automation. Your API calls, your scripts, everything uses that exact namespace path. If you rename a parent group,
You break everything.
you break everything that points to the old address. So that's another huge admin responsibility, keeping those high-level namespaces stable. They're not just friendly names, they're critical identifiers.
And I assume the system enforces uniqueness.
Of course, you can't have two engineering groups under the same parent. The system wouldn't know which GitLab.com pecomp engineering you meant. It has to be a clear, unambiguous path.
Wow. Okay, it all connects. The hierarchy, the permissions, the security, it all boils down to this one readable URL.
It shows you that groups aren't just tags. They're the literal database schema for your entire organization on the platform.
All right, this has been a really solid deep dive. Let's try to boil this down to the key takeaways for you, the listener, so this all sticks. When you think of GitLab Groups now, there are 4 pillars. First, groups are your admin engine. They aren't just folders. They're smart containers for people, permissions, and projects.
Second, efficiency comes from inheritance. That's the mechanism that cascades permissions down so you can manage users at scale.
Third is security, and that's the visibility ceiling. The big rule: a child can't be more visible than its parent. The top level sets the max exposure for everything below it.
And finally, organization is handled by namespaces. That's the unique address system that gives you predictable URLs and makes your automation reliable. You master those 4, and you've basically mastered GitLab administration.
So here's the final thought, and it connects back to that 20-level depth and the sheer power we've been talking about. If all that administrative control is so concentrated at the top, what does that really mean for the person in charge?
And that's the provocative thought to leave you with. Think about the scale of responsibility. Because that visibility setting cascades down all 20 potential levels, a single mistake is catastrophic.
Right.
Imagine a top-level group. It's meant to be private. It holds years of your company's most secret work, and an admin accidentally clicks it to public for just 5 minutes.
Oh, wow.
In that instant, that one click has potentially exposed every single line of code in hundreds of projects across the entire global organization. It shows that group administration isn't just an IT chore. It is mission-critical data security.
The same tool that gives you incredible efficiency at scale is also the single point of failure for massive exposure.
The weight of that responsibility is immense. So think about that as you build your own structures.
That is some fantastic guidance. Thank you for walking us through that. We will catch you next time as we keep unpacking the tech world.